Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, today I'm finally going to cover a topic that I really thought I would have covered by now. Here it is. Expand the Horner OCS using SmartMod I. Now at Horner, we provide our customers with quite a few different options when they want to expand the I/O beyond what's built into their OCS all-in-one controller. We don't just have one or two families, we have several. And today we're going to cover a family that I've never really talked about before on this channel, and that is SmartMod I. So without further ado, let's go ahead and dive right in. Okay, we're going to start by talking about Horner Expansion I/O in general before we dive into SmartMod I/O in particular. We're going to go through the SmartMod I/O module lineup. We're going to talk about what you need to do to physically connect SmartMod I/O to OCS. We're going to go through configuration of SmartMod in Cscape, and of course, we're going to have demonstrations. All right, let's go. All right, so let's start with some of the more common I/O platforms available to Horner customers. We'll start with the newest platform, and that is OCS I/O. Now, one of the reasons I'm going through these different platforms with you is because I think a lot of customers get nervous that they're going to pick the wrong I/O family for their application. Now, in general, there really aren't that many wrong answers, but I think the information we give today is going to help with that, I guess, level of concern. All right, so let's get started with OCS I/O, which is our newest I/O family. Now, in general, if you've got a new application, OCS I/O is probably the one you're going to start with. In other words, that's the one you're going to look at first, okay? Because it's best for most new applications. It works really well in applications which need just a little bit of I/O or a lot of I/O. It works well with just about every Horner OCS that's out there. So that's really the one you're going to look at first. Now, if you need to add digital I/O and maybe 16 or 32 point blocks at a time, SmartSticks I/O might be one you want to take a look at. If you need high-end or high-performance analog, SmartBlock does that very well. Maybe you've got high density or high mix, SmartRail would be an I/O platform you'd take a look at. But once again, you're probably going to start out by looking at OCS I/O. But where does that leave SmartMod? Where does SmartMod fit? Well, in general, SmartMod is a great platform if you just need to add a few channels of lower cost analog to an application. SmartMod I/O connects to the OCS over Modbus RTU, and every OCS supports Modbus RTU, which means you can use SmartMod with any OCS product family. Now, the other product families I showed on the previous screen, they mostly connect over CSCAN, which is the Horner proprietary CAN network, although SmartRail also has an Ethernet option as well. But SmartMod, on the other hand, is an RS-45 type connection. Okay, let's take a quick look at the lineup of SmartMod I/O options. Now, we're highlighting analog today because that's really the best way of utilizing SmartMod. There are a couple of digital I/O options, but generally we're going to highlight analog today. All right, so as you can see, there are quite a few different options from 4 to 20 milliamps, specifically, I guess, 0 to 20 milliamps, voltage inputs, plus or minus 10 volts, and then RTD and thermocouple temperature sensors. And you can see those are available in 4-channel and 8-channel type options. And they have nice resolution to them. As you can see, that's somewhere in the 15-bit resolution range, so pretty nice there. And then on the analog output side, you have 2-channel, 4-channel, and 8-channel options. So again, if you just need to add a little bit of extra analog to your application, SmartMod I/O can do that pretty well. Okay, let's take a look at the connections on a typical SmartMod I/O module. And I've got a 4-channel voltage analog input card that we're looking at here. Okay, so on the left is the I/O terminals. Now, of course, that's going to vary depending on which module in particular that you have in terms of the specific I/O connections that you're going to make. But the right-hand side of the module is going to pretty much be the same on every model. At the top right there, you have your Modbus connections, which is typically 3 wires. You've got a twisted pair, data plus and data minus, and then a common terminal, which is used for a ground reference. All right, so typically you're going to have 2 twisted pairs with 1 pair for data and 1 other conductor of the second pair used for common. And then at the bottom right there, you can see the power input, which is wide range DC, so it can support 12 and 24 volt input voltages. So in terms of the physical connections for RS-485, as I mentioned a minute ago, you're going to use multiple twisted pairs wiring, okay, for your signal pair and for your signal common. Now, if you want to use Cat5 cable or some other category cable like Cat6, etc., that would be fine. Now, you're only going to use a couple of the pair. You're not going to use, all 8 conductors, for instance, but it would actually be a pretty good choice, especially if you're simply connecting a SmartMod module to an OCS in the same enclosure. As a matter of fact, you could take a patch cable, an Ethernet style patch cable, chop off one end, and then just use 3 of the conductors to wire up to your SmartMod. And that's something I've shown on the screen here with the pinout that also includes, for those people who are going to cut off a patch cable or build their own, I guess, using Cat5, I've also shown the color codes there to make things easier. Now, because it is RS-485, there is termination that's required, a 100 ohm termination on each end. Now, on the module end, you could use a physical 100 ohm resistor between data plus and data minus. And then on the OCS side, it's probably going to be easier to either flip a dip switch, because some models use a dip switch for termination on RS-485 on the OCS end, and then other models have a system menu entry for setting termination on the OCS end. So that's probably going to be easier instead of dealing with a resistor on the OCS side, again, if the OCS is on the end. Now, let's talk about configuration. Let's start by the fact that SmartMod modules are RTU slaves, which means you're going to configure the OCS as a Modbus RTU master. Now, I would absolutely recommend you use the default serial parameters. They're going to work extremely well and be plenty fast enough for most analog applications. And those default parameters are 38400 baud, no parity, 8 data bits, 1 stop bit. Now, from the standpoint of any configuration that has to be done or reading data at runtime, that's all done through Modbus registers. Now, the configuration data and the I/O data is mapped to Modbus holding registers. And in the case of the thermocouple and RTD, there's some diagnostic data that's available in Modbus coils, specifically open circuit data in case one of your thermocoupler or RTDs fails open. Now, let's take a look at some key Modbus registers for interfacing with SmartMod. Now, in some cases, you need to configure the sensor type. Okay, if you're using an RTD or a thermocouple module, it's possible that the default sensor type isn't what you need, so therefore you need to set that to the value for your application. And if you're going to do that, you're going to write to Modbus holding register 40011. And the top 2 charts there on the screen are showing you the different decimal values that you would set for different sensor types. Now, if you're using one of the DAC 007 or DAC 107 modules, those are configurable for current and voltage, okay? And if current isn't what you need on each channel, then you're going to want to change Modbus holding register 40014 on those modules to set current or voltage. Again, only if the default of current doesn't match what you need. Now, for reading or writing the analog data itself, that's all available starting at holding register 40015. All right, so if you've got 2 channels, it's going to be 15 and 16. If you've got 8 channels, it's going to go all the way from 40015 up to 40022. And then if you're using RTD or thermocouples and you want to take advantage of the fact that the modules can detect an open circuit, then you're going to want to read Modbus coils 1 through 8 for that. Now, in 99% of applications, you've just got one SmartMod connected to an OCS. Because remember, what SmartMod does really well is add a little bit of extra analog I/O to a typical application. Now, if you do happen to have more than one module in your application, then you're going to have to change the default Modbus ID for any modules other than the first one. Okay, and that's done by writing to Modbus holding register 40,007. And again, that's only required if you have more than one SmartMod module, and it's only required on the modules other than the first one. Okay, so let's talk about an example configuration that we might need to do if we needed to add, let's say, 8 channels of thermocouple input to our application. So we might use a SmartMod THM200 module that has 8 thermocouple inputs. Maybe what we need is type K thermocouples, and that's not the default for that module. So we're going to have to set the type to type K, and we're going to do that by writing to holding register 40,011. And then the temperature values that we read are going to be coming into Modbus holding register starting at 40,015. And there's going to be 8 of them, and they're coming in 10th degree C increments. So if we're going to want to leave them in degrees C, then we'll probably convert that analog value that we read over Modbus into a floating point value and divide it by 10. If we want to convert them to degrees F, we're going to take that Modbus value, convert it to floating point, divide by 10, multiply by 1.8, and add 32. That's the equations we would use in those scenarios. So let's go ahead and fire up Cscape and take a look at this configuration. Okay, for SmartMod, while we're in Cscape, we always start with our Modbus configuration because that's how SmartMod interfaces with the OCS. So I'm going to go to Hardware Configuration. I'm going to go down to Serial Ports because that's where you can find Modbus RTU. Go to Configure. And then most OCSs have 2 serial ports, MJ1 and MJ2. Some of them also have a third, MJ3. And RS-45 is available on MJ2 and MJ3 if it's there. Okay, so in my case, I've got a micro OCS model I'm configuring here, so I only have MJ2. And from this drop-down list, I have selected Modbus Master from the choices. Okay, and then I have 3 levels of configuration. So let's get started and take a look at the first level. Okay, so this is where I set Modbus RTU as my protocol and then all my serial parameters. So 38400, N81 are the defaults. You absolutely should use the defaults. In terms of retries, I'm leaving that alone. We'll do 2 retries, the OCS will, as it's communicating with the SmartMod I/O. We are going to adjust our timeout quite a bit lower. So 1 second is plenty of time for the OCS to wait for a SmartMod to respond. It'll typically respond in way less than that. So those are the configuration options that I recommend for the port configuration. Now on the update scan, leave it as automatic with an update interval of 0, which means go as fast as you can. And under reacquire time, I've dropped that down to 1 second as well. So if we don't get response from the SmartMod, we'll try 2 more times. We'll take the unit offline, and then a second later, we'll just repeat the whole process over again. So that's what I recommend at least. Okay, down here under Disable Network, this is kind of an optional type variable you could assign as a disable network function. So whenever this bit turns on, if you assign it, you're effectively going to be temporarily disabling Modbus, which you can think of as kind of a Modbus reset, if you will, so that when you clear that bit again, Modbus will effectively have been reset. Now, I definitely recommend that you take advantage of SmartMod Master Status, which is 4 double integer values. The first of which, when it's reported, I've assigned it to a double integer based array here. The first value when it comes back will tell you in milliseconds how long it's taking for the OCS to poll the SmartMod I/O module. The second value tells you how many no responses the OCS is getting. The third, how many bad responses the OCS is getting. And the fourth, how many good responses the OCS is getting. So at runtime, what you want to see is that fourth value incrementing up on a continuous basis, the second and third values hovering near 0, and that first value telling you in terms of milliseconds how long it's taking to pull the SmartMod I/O module. Okay, so that's the network level of configuration. Now let's go to the device level. I've already added my SmartMod here. Let's double click and take a look at my settings. Okay, I've assigned a name, just a convenient name that I want to call it. The default ID is 1 for SmartMod, and so you want to leave that alone. Now, the only reason you'd ever need to change this is if you had multiple SmartMods, but the first one would still have a ID of 1. All right. Now, in terms of the addressing, we stick with Modicon 5-digit addressing. That's fine. The device supports all the function codes. Now, in this particular case, I have not added the disabled device variable here, which is Boolean type, because I've only got a single module, so there's no reason to disable that one module. I also have not enabled status for this particular module. I could have, it would have given me a little more information. In this case, I'm just counting on those 4 double words that I talked about in the status on the last dialog box there, the good responses, etc. Okay, so that's my device level configuration. Now let's take a look at my scan list, okay? And in this particular case, I have 3 entries in my scan list because I have a thermocouple module and I'm taking advantage of a couple different things. So let's start with the first entry in the list. This is accessing only Modbus holding register 40,011. What is that doing? Well, this is a read-write variable or value that I can write, which sets the type of thermocouple that I'm using in my application. And in my application, I'm using type K, which was not the default. So I'm going to have to write to this value in this analog register periodically. Now, I chose a polled read-write init because what that means is at power up, the OCS is going to write the value to make sure it's set properly to the value that the OCS wants. And then the OCS will go back to just reading that value and making sure it matches. Okay, so that's what I've chosen for 40,011, which is used to set my thermocouple type in this case. Now, my next entry in the scan list is where I'm reading my 8 channels of data. Now, if I only had 4 channels of data, my length would be 4, but I've got 8 channels. We're starting with Modbus holding register 40,015, and again, putting the number of registers or the number of channels that I need to read, and I'm reading those into a integer-based array that has 8 values in it, okay? And so I'm just putting the starting variable value here, okay, which has an index of 0, of course, and this is a polled read because I'm only ever going to read those temperature inputs. I'm never going to write those. Okay, so those are my 8 temperature values that I'm reading. Again, if I only had 4, my length would be 4. And then finally, because this is a thermocouple or RTD module, I do have available to me the ability to read coils, Modbus coils, that tell me if my sensors are, any of my sensors are open circuit or not. So I want to take advantage of that. So I assign Modbus coil starting at 1 with a length of 8 because I have 8 channels. And I have assigned those to a Boolean variable array. And of course, I put the first entry in that array here on the screen. And this again is a polled read because I'm never going to write this data. Okay, so that is really all that's required on the configuration side. I'll just briefly show you the screen that I've created to display temperature values. So you can see those here. Let me go ahead and maximize that. Okay, so I've got my 8 different temperature values. Now I went ahead and displayed them in their native format. So I selected signed decimal because these could be negative values. Remember, they're coming back in 10th degree C increments. So I'm just displaying the data directly that I'm reading in from my array value, displaying it with the proper decimal point location, and then adding an engineering unit of degree C. Okay, and I'm doing that for each of the 8 channels, just having a different array member, of course, for each of the 8 different channels. And then I have my open circuit coils here that I'm reading that again have also been assigned to, this time, a Boolean style array. So if any of my sensors are open circuit, then these pilot lights are going to turn red. All right, that's really all there is to the configuration for Seascape for the SmartMod I/O module. Okay, that does it for our program for today. But before I close, I'll remind you that we're here every Tuesday at 2 o'clock. Whether we're fully live or whether we're pre-recorded, but we always have someone standing by if you're watching live to answer any questions from the chat section. And if you're watching on replay, we'll answer those questions. Just leave them for us in the comment section. Okay, don't forget to sign up for OCS training this year. We've got basic and advanced courses you can see on the screen. Sign up on our website. Okay, you've got a lot of ways to interact with Horner online, either from our website or our YouTube channel or over LinkedIn. So we look forward to connecting with you soon. Okay, next week we have an exciting show for you. We are going to be fully live from Automate on Wednesday, not Tuesday, but on Wednesday. So join us Wednesday, May 8th at 2 o'clock. We're going to be fully live. We're going to give you a tour of the booth. We're going to talk about some products you have not seen before. We haven't even previewed them before. So it's going to be pretty exciting stuff. So join us next week, Wednesday, May 8th at 2 o'clock. Okay, if you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next Wednesday, let's all get out there and do us some good.